Welcome to Anson Griffith's Occasional Series and YouTube tutorials. Today we're looking at the Classification Learner app in MATLAB. This is new, i.e. 2016A and on, and this is much better than the previous way of doing it for the beginner, may I say. If you're an experienced guy, that's a different thing, but you just want to get the classification to work. So we're going to look at the Fisher-Ayers dataset, which we'll look at in a minute, and we're going to look at all these decision trees. The trees, support vector machines, nearest neighbor classifiers, and various ensemble classifiers, Ada, Boost, etc., etc. And we're going to run all of them. There's around 20, 25, something like that, and we're going to select the best classifier. So what I'm going to do is I'm going to tidy up my workspace. They're the ones, just as comments I'm going to do, and I'm going to read in the Fisher-Ayers table. So I just go out to my command prompt here. Let's just have a look at what's there. So there's Fisher table that I've read in. And so if you haven't seen this before, Fisher was a famous scientist, and he wanted to classify 3 different types of irises. So he looked at sepal length, sepal width, petal length, and petal width. The first 50 in the data set are Setosa. The second 50 are versicolor. And the third 50 are Virginia, and we just want to classify that. So we've done that, and then later on, we see now when I say later on in a minute or so, you have to have it as a table. So load is no good. You have to say read table. You have to convert the CSV file into a table. So we're up here on our apps. We go to Classification Learner. New session from the workspace, which is the Fisher table. There we are. So there's the 4 predictors. It guesses. You can change them if you want, but it's quite good. It'll just say the numerics are the predictors, and it'll probably say the cell or the text or whatever it is a response. So that's grand. You can select a number here, but what we're going to do is we're going to select all the classifiers, and then we're going to train. And this is going to take, I don't know, a minute, 90 seconds, something like that. So you can see here we're in the queue, and it's going to train each of the 22. So we're just going to have to wait. Okay, so it's done it, and if I just scroll up here a little bit, it sort of highlighted the best one for us. That's the linear support vector machine. It's okay. You see here, it's given it to us. This plot is for the one I'm on at the moment. And we have that there. And just imagine there's a bit of confusion there. So it's 97.3 accurate. You can see this if we look at the confusion matrix. So there we are. Now the more that lie on, I got 4 of the versicolor wrong. Classified 4 of them as Virginica. So ideally you want 50, 50, 50. And the more you have lying off the leading diagonal, the less accurate your classifier is. But anyway, we're 97.3%. That's grand. So we've done all of that, and then you're probably saying, how do I test this on new data? You say this. And I think this is probably the simplest one. And I'm going to call this train classifier, yeah. So it's exported that classifier to the workspace. If I go back to here, I made up a new data set. Now these names have to be the same as the original in the Fisher table, just there. So I made up some numbers. On line 17, I created a new Fisher iris table. And on the right hand side, I said table. So create a table from the matrix petal width, sepal width, and sepal length. And then here we go. Train that classifier. That's the lad we just created a few seconds ago. The dot predict function using the new data. So I'm just going to, I suppose I could run it, but I'm just going to copy and paste that in. And it's named, so it says the first one is Setosa, that's second and third is Virginica, fourth is Setosa, that's her. Fifth and sixth is Virginica. Now I don't know if that's right or not, because I just made up those numbers, so I have no idea, but that's what it predicts. Okay, so hope that helps. Thanks very much for listening.